Truss problems. So we have to evaluate vertical deflection at the point C of the truss given here. So first let us use Castigliano's method for evaluating this deflection. Castigliano's method. So the same procedure you have to follow. First apply a force Q at C where deflection is required. Where vertical deflection is required, so therefore you have to apply a vertical load Q in that direction where deflection is required, as in figure. Required as in figure. Then YC is given by sigma of Pfi delta Fi by delta Q Li divided by ADI. Because it's a truss, we have to use the equation for the axially loaded member, that is P delta Fi delta Q into Li by ADI, where this Q is the load applied and Fi is the force in all the members. Any member I is equal to 1 to N. Fi is the force in any member I, and AEI is the axial rigidity of any member I, Li is the length of the member I, and that Fi is in terms of Q, because we are applying a load Q. In terms of Q only we get the force in all the members. That force we have to differentiate partially. That's all the change we have from the other members. Because this is axially loaded, we have to use this equation. That's the only change. So we have to find out Fi, so you can say there where Fi is the force in any member, force in any member I of the truss due to this load Q as well as any other load acting on the truss, that also have to take. And Li is length of any member I of the truss. AEI is the axial rigidity of, that is axial rigidity. Axial rigidity of any member of the, any member I of the truss, and delta F, delta Q is the first derivative of the force. That you have to say. So that means you have to find out Fi as well as Li. So first find out, to find Fi forces. So you have to adopt your usual method of analysis of the truss, either method of joints or method of sections. So we will adopt method of joint here. First, in the method of joint, you have to select a joint wherein not more than two unknown forces are there. Here there are only two members, only one joint. So straight away we can take that joint C straight away and indicate the direction of the member forces meeting at that point G with C with their positive direction. This we call it as FCB in that positive direction, that is tension arrow moving away. Here it is FCA, and this angle you can take it as theta. And here the values given are 2 meters, and depth is also 2 meters. So we have to find this angle theta from this. If it is given straight away, you can use it. So here we have a force Q, and we are applying a force Q at C as indicated. You take this free body diagram of joint C, because only one joint is there, you take that and apply. You have two equations of statics, sum of all horizontal forces 0 and sum of all vertical forces 0. First we will take sum of all horizontal forces 0. You will get FCB cos theta plus minus, because FCB cos theta is in this direction, FCA cos theta is in the opposite direction, that is minus FCA cos theta is equal to 0, because there is no horizontal force at the joint C. Or you can say this cos theta will cancel. You will have FCB is equal to FCA. That's the first relationship you will get. So then you apply sigma V equals 0, you will get FCB sin theta plus FCA sin theta. Here it is plus, because both are acting in the upper direction, the result components, and Q is acting down. So this will be equal to Q. Right? And FCB is equal to FCA. So, or you can say twice FCB sin theta is equal to
20.
Q, because FCA is equal to FCA. That is from the previous equation. Therefore, FCB is equal to Q by 2 sin theta. What is sin theta? Sin theta is opposite side by this hypotenuse. Hypotenuse will be 2 square plus 2 square root. That is square root of 4 plus 4, that is 8. That you will get it as 2 root 2. Here also 2 root 2. So sin theta will be 2 by 2 root 2. So this is 2 by 2 root 2, or Q root 2 divided by 4.
Yes.
So this Q by 2 into sin theta is 2 by 2 root 2. Correct?
Yes, sir.
This is sin theta. This 2 will cancel, or you will get Q root 2 divided by 2, or it is Q by root 2. Similarly, FCA is equal to FCB is equal to Q by root 2. So you get the forces here. PI forces you are going to get like this, both in the same direction. So this is C, this is positive. We have taken, we are getting same positive result, 2 by root 2. Here also it has to be like that. So this is 2 by root 2, this is 2 by root 2. You got PI, F5 forces. F5 forces in all the members. There are only 2 members, both in CA and CB, they are that. That's all. Now, so you prepare the table. So you say member. So there are only 2 members, CA, CB, and AE of the member, member I, any member I, right? In the formula, I have told any member I, there are two members, CA, CB, AE of that member, AE is constant. If it is valid, you write that value, take the corresponding value, either numerically given values or general values like this, AE, and Li, length of the member, that is equal to 2 root 2, that we have determined already, 2 root 2, that one and the same, then F5, that you have determined here, that is Q by root 2, here also it is Q by root 2. Then find delta F5 by delta Q, because we need to have found out F5 in all the members. I is equal to 1, 2, 2, because there are two members. I have determined this F5. Delta F5 delta Q, I determined this Li, AEI, already I have tabulated. All these values I will substitute, add I is equal to 1 to as many number of members which are there in the total structure. I get that YC straight away. That's all the simple calculation. It is nothing but analysis of that analysis you have to do perfectly. So this delta F5 by delta Q is 1 by root 2. Here also it is 1 by root 2. That's all. Therefore, then YC, that is from this equation 1. Therefore, YC from 1, from that equation 1 is equal to, say F5 delta F of this member first, Q by root 2 into 1 by root 2, that is equal to Q by root 2 into 1 by root 2 divided into N. That I will do it in the table itself. And okay, I will do it here itself. F5 delta F5 by delta Q into Li divided by AI, AE. Straight away I will compute in that last column that entire value, that sum I will evaluate. That's all. I will get YC straight away in the table itself. So there this into this into this. This is Li, this is F5, this is delta F5 by delta Q. These three columns I have to multiply. Okay? This root 2, that is 2, that 2 and this 2 get cancelled. You have just Q root 2. Here also root 2, that 2 get cancelled. You have just Q root 2 divided by AEI is AE. Here also it is AE. This sum is 2Q root 2 by AE, or write that 2Q by root 2 AE, or this root 2Q you can write it. So therefore YC is equal to 2Q by root 2 AE divided by AE, or this is root 2Q divided by AE. Now we can put value of Q. Q value is given there as 20.
So it is also divided by, right, sir? Sigma, sigma value. Sigma.
Where?
Sigma. 2Q.
This sigma equals 2Q.
2Q by root 2, not
2Q root 2.
Yes, sir.
Sir, this is 2Q
Root 2 divided by
2 divided by
A.
AE. So that means this is root 2 by
Yes, sir.
AE. But Q is equal to 20 kilonewtons. Therefore, YC is equal to 20. Is it okay?
Root 2 into 20.
This is 2 plus root 2 plus Q root 2 is 2Q root 2. That is 2Q root 2.
Root 2.
Oh,
Yes, sir.
here it is 2Q
root 2
root 2 divided by
AE.
Here 2 root 2Q divided by AE up to equals 20. Therefore, it is 40 root 2 divided by AE. That's all. So in about 5 or 10 minutes you can solve it. Now the same problem, let us work by dummy load method. Let it continue.
Yes, sir.
Okay. So let us take up that second, that we will examine whether we are going to